Together, we will examine the astonishing beings in the darkest points and most mysterious places of the universe. Space has a very large area that contains countless mysteries. It is estimated that the universe, which contains many different celestial bodies, also hosts very difficult and interesting celestial bodies such as black holes and white holes, whose existence is only an assumption that has not been proven definitely. Before moving on to white holes, which are mathematically defined as the opposite of black holes, let's remember black holes. Black holes are regions of the universe where the escape velocity exceeds the speed of light as a result of very intense compression of matter and energy. A few it takes some pretty fancy math to fully describe a black hole, yet they are real objects in the universe. They were predicted by Einstein's theory of relativity and were indeed discovered in recent years. In fact, a black hole was photographed and published for the first time in April 2019. Black holes form when stars much more massive than our sun die as supernovae. So what is a white hole? There are so many beings to be discovered in the universe that they could be waiting to be discovered in white holes. When mathematically examining the surroundings of a black hole, assuming there is no mass at its event horizon, white holes are assumed to emerge. Or white holes could be a massless black hole singularity. He studied black holes thoroughly before moving on to so-called white holes. In astrophysics, a black hole is a very massive cosmic object whose gravitational field is so strong that it does not allow all kinds of material formations and radiation to escape from it. We can also say that a black hole occurs when a certain amount of matter accumulates at a point in space. It is estimated that time beats slowly or does not flow inside black holes. Black holes are described by Einstein's theory of general relativity. Although they cannot be observed directly, they were discovered thanks to indirect observation techniques using various wavelengths. Today, the existence of black holes has been confirmed by almost all members of the scientific community. That is, astrophysicists and theoretical physicists. A black hole has mass concentrated to a point called a gravitational singularity. This mass forms a sphere called the event horizon of the black hole, centered on the singularity in question. This sphere can also be thought of as the place occupied by the black hole in space. When it comes to interstellar distances, a black hole does not exert a gravitational force on any cosmic object greater than that of a cosmic object of the same mass. So we should not think of black holes as an irresistible cosmic aspirator. For example, if there was a black hole with the same mass in place of the Sun, there would be no change in the orbits of the planets in the solar system. There are many types of black holes in the universe. The type of black hole formed by the gravitational inward collapse of a star is called a stellar black hole. If these black holes are located at the centers of galaxies, they can have a huge mass, up to several billion solar masses. And in this case, they are called giant black holes or galactic black holes. It is thought that between the two species that form the 2 points of black holes in terms of mass, there is also a third species with a mass of several thousand solar masses. And this type is called intermediate black holes. Black holes with the lowest mass are thought to have formed in the Big Explosion at the beginning of the history of the cosmos, and these are called primordial black holes. However, the existence of primordial black holes has not yet been confirmed. It is impossible to observe a black hole directly. As it is known, in order for an object to be seen, light must come from it, or reflect the light coming to it. However, black holes absorb even the light that passes very close to them. However, its existence is understood from the fact that the nearby matter falling on the black hole, especially in microquasars and active galaxy nuclei, is extremely heated and emits X-rays strongly due to the gravitational movement on its surroundings. Thus, observations reveal the existence of such objects of giant or small sizes. The only objects covered by these observations that comply with the general theory of relativity are black holes. It can be said that the concept of black hole was first born at the end of the 18th century within the scope of Milton's law of universal gravitation. But at that time, the only question was to know whether there were objects that were massive enough to have an escape velocity greater than the speed of light. Therefore, the concept of black holes ceased to be a fantastic concept only at the beginning of the 20th century, especially with the introduction of Albert Einstein's theory of general relativity. A black hole is an astrophysical object. It is characterized by being very difficult to observe directly, and by the fact that its central region cannot be satisfactorily described by physical theories. The most important factor why its central region cannot be defined is that it contains a gravitational singularity at its center. This gravitational singularity can only be described with a quantum gravity theory, which does not exist today. On the other hand, black holes are surprising objects in that they are defined by a very small number of parameters. Their definition in the universe we live in depends on only 3 parameters: mass, electrical charge, and angular momentum. All other parameters of black holes are determined by them. To make a comparison, for example, there are hundreds of parameters in defining a planet. Cosmic bodies, which periodically identify around their own axis, tend to drag the spacetime in their immediate surroundings. The 2 surfaces around the rotating black hole appear to be static inside. It is the inner limit of the ergosphere. The oval-shaped surface touching the event horizon at the poles is the other boundary of the ergosphere. A particle inside the ergosphere is in space-time drift and is forced to spin. This is the enduro sound process. The belt surrounding the region where light and matter can no longer escape is called the event horizon. The event horizon is a piece of space that we cannot make any physical examination of. There is no way to explain what goes beyond the event with known laws, and there is no way to know what is going on there.